This is BTEC Engineering, Unit 7, Sections B5 to B8. So we need to turn to page 5 of the Section B Examples booklet. Again, this is a video, so you will need to pause to take notes. So, on B5, we have to use definite integration to find out how far the vehicle has travelled in 4 seconds, given that v equals t squared minus 2t plus 3. To get pass grade, you need to be able to do this correctly. If you want to get merit or distinction, you're going to have to explain your method. Now, this is quite complicated maths, so what you need to be able to, is, at the very least, is to do the process with different numbers, basically. So this function with different numbers, for say the minus 2 to 3, we may need to follow it through with different numbers. If you understand it, great, you'll be more likely to get merit or distinction, but at the very least, for the pass, you'll need to be able to follow this process through with any set of numbers we start with. So in this case, do definite integration. Now, the symbol I'm about to draw is what's called an integral symbol. So this symbol basically means we need to integrate. Now we want to integrate the function that we're given, because we integrate our velocity in terms of v to get our distance, which we usually call s, the displacement. Now, when we're writing an integral, we have an integral symbol at the start. We have a dt at the end if we're integrating with respect to t. So in a sense, these symbols are like mathematical shorthands. Now for a definite integration, we need limits on here, what we're integrating between. Now we're trying to find how far the vehicle has travelled in 4 seconds. So we're starting at 0 seconds and we're going up to 4 seconds. Right, now we integrate, and again we need a certain type of notation, so we have we use square brackets for our integration. Unlike the indefinite integration for B1 to B4, we don't need to put a plus c, because we're going to be actually sticking numbers into the integrated function. So the plus c would cancel out, as you'll see from the process. So again, it's the same rules for polynomials for integration as it was back in B1. We add 1 to the power and we divide by the new power. T on its own is t to the power of 1, so we add 1 to the power, divide by the new power, and any number, when we integrate, we put a t at the end. And the limits are 4 and 0. So after we've integrated, we put the result in square brackets and the limits go on the outside of the square brackets on the right hand side. Tidying it up, 2 plus 1 is 3. 1 plus 1 is 2. 2 divided by 1 plus 1, you can stick into a calculator, as we would do like that, 2 over 1 plus 1, using the fraction button. It will basically tell you that's equal to 1, so that's equal to 1 times minus t squared plus 3t. Now when you've got limits for an integration, the first thing you do is to stick the top number into the formula. So wherever a t is, we would put 4. So 4 cubed over 3 minus 4 squared plus 3 times 4. Take away, then you put the bottom number into the formula. So 0 cubed over 3 minus 0 squared plus 3 times 0. It should be clear that this bracket will just be equal to 0, so we only really need to calculate that one. But if you want to just get in the habit, you might want to put the whole calculation, including brackets, into your calculator. And we get an answer of 17.3 to 3 significant figures. We're finding distance in meters, so the answer is 17.3 meters. So this is the minimum you'll need to be able to do a pass. Obviously you'll have a different function for the real assignment. If you learn more about this and you really understand it, you'll be able to get the merits and distinctions to explain your method. But as far as the process goes, you need to be able to follow the same steps, exactly the same steps, but with slightly different numbers. Right, so that's B1, moving on to B2. No, sorry, B5, moving on to B6. So we're now on page 6 of the examples booklet. So we've got 4 cos t that we need to integrate this time. So it's the same process. So this time we're going in pi over 2 seconds, so 0 to pi over 2, 4 cos t. Important, the angle is in radians because integration and differentiation only works in trig functions if you're in radians. But we're doing the same process, integrate, stick the limits in, and so on. Now integrating, we'll need the square brackets. Cos t integrates to sine t, whatever the number is at the front stays, so we get 4 sine t. So the cos t turns to sine t when we integrate. Again, we stick the top limit in first. Take away, same thing, put the bottom limit in. Make sure your calculator's in radians. So if it's not in radians, then it's shift mode and 4 if you've got the Casio calculators. So now my calculator's in radians, I will stick it in. Now because of the way the calculators work, you'll need to put brackets around the pi over 2 and the 0. So the calculator knows what it's doing sine of. And it gives us an answer of 4 and the units meters for distance. So that's B6. Going on to B7. So I'm now on page 7 of the examples booklet. And this time the function we need to integrate is 15e to the 5t. We're travelling in 4 seconds, so our distance, the integral from 0 to 4 of 15e to the 5t, the t. So we need to be able to integrate that function. So integrating an e to the power function, whatever the number is before the t, we need to divide by that. So 15 divided by 5, e to the 5t, the limits are 4 and 0. Simplifying, 15 divided by 5 is equal to 3. And again, just like the other examples, first we put the 4 in for t, so 5 times 4. Take away, we put the 0 in for t. And we calculate it on the calculator. We got a massive number this time, so 14554955583 metres. Might want to round that to 3 significant figures. So moving on to the next one. And final one for this video. We're on B8 on page 8. So same process, different formula. It's up to 4 seconds again. Formula is now 3 over 3t plus 4. So the limits are 0 and 4 still. The integral of 3 over 3t plus 4 to t. We need to integrate. Now, as long as the number in front of the t and the number in the numerator are the same, this will integrate to ln of the denominator, so ln of the 3t plus 4, and close the square brackets, limits on the outside. I'll say 4, we stick the top number in first into the formula, so ln of 3 times 4 plus 4. Take away ln, we put the bottom number in for t, 3 times 0 plus 4, stick it into the calculator, so ln 3 times 4 plus 4, close bracket, minus ln of 3 times 0 plus 4, close bracket, and on to 3 significant figures we get 1.39, and the unit is still metres. So for all 4, B5, B6, B7, B8, these are the processes. At the very least, you're going to need to see what happens to each number as you run through the process and change the answers from the example for the assigned ones by changing the corresponding numbers and following it through in the same way. Best of luck.